All right, students, so good evening. And so it's good to be here again with you at another class, journeying on this experience with the CSEC math. Now, we have been looking at subset from the previous lesson. We had looked at how to looked at the symbol, we look at how to list subsets, and we talk about different types of subsets. And we saw where we have two main types of subsets. We have proper and we have improper subsets. And so you should have a sense of what those are. So what we're going to be looking at next, we're going to be looking at the number of subsets. Now, in the previous listing, when we list these subsets, you would have realized that for A, if you count the number of subsets you get from A, you would get how many subsets you get from the set A. Count them and tell me how many you get. How many subsets? So you get 8 from set A. But if you notice the set B, how many subsets you count from set B?
$16, sir.
16. Now, so there's a relationship with the number of subsets that you obtain with how many members are in the set, right? So the amount of members in the set can actually help you to determine how many subsets you're supposed to get, because there's a formula that relates the number of members in the set with the number of subsets that you can form. So for the set A, you notice that you have 3 members in set A and you end up with 8 subsets. For the set B, you have 4 members in the set and you end up with 16 subsets. Now, if you have 5 members in a set, how many members you would expect to end up with? How many subsets would you expect to end up with based on that pattern that you're seeing so far? So if 3 give you 8 and 4 give you 16, what you expect from 5?
24, sir.
24. And what would make you come to that conclusion? Do you see a pattern with the numbers?
All right, sir. Yeah. Each time you have an extra number in a set, you add 8 to the set. You add 8 to the previous number.
All right. So that might look as if that's what's happening, but actually, if you have 5 members in the set, you're going to get 32 subsets. All right, so with that said, can you think of a formula that you use to determine how many subsets you would have? So here you have 3 members, you have 8. If you have 4 members, you have 16. And if you have 5 members, you're going to have 32. Is there any formula or law that you could come up with that would be able to determine the number of subsets based on how many members you have? Just giving you a chance to brainstorm that idea. Anybody come up with anything?
Sir, repeat that again for me, please.
So based on the pattern that we would have looked at just now, if we have 3 members in a set, you will have eight subsets being formed. If you have 4 members in a set, you have 16 subsets being formed. And if you have 5 members in a set, you will have 32 subsets being formed. So I'm asking you, can you come up with a formula that would be able to tell you how many subsets you can form based on the number of members that you have in the set?
Sir, we could use for the unknown, we could use it to X to represent the unknown.
All
so
right.
like you'd multiply the unknown times.
Let me write what you're saying. So you do what? Have an X for the unknown.
Yes, sir.
Go ahead.
Sure. Well, that's everything about you again.
Okay. In the meantime, anybody else have any idea? Is there anybody else who would like to try? I guess nobody has any idea. All right. Ms. Waysam, are you coming up with anything else?
So I'm not really sure if for me it makes sense.
All right.
So as necessary, I probably use just like how you say, like we see the pattern where 8 is in one and then 16 is in one and then 24. So I'm saying, sir, that all right, for the amount would have been in the set, we could use the X to represent that amount, sir, and then by the next set would have probably I'm not sure.
There's a correction to the last one. The last one wouldn't be 24, it would be 32.
It will be 32?
Yes.
Even the 8. Oh, so it's actually multiplying. So that means then, sir, if that is the case, then, sir, the amount in the set then, you'd multiply it by 2. Because because 2 times 8 would have been 16, sir, and then 16 times 2 is 32.
All right, but how would that relate to the number of members?
So you'd have 2 times X, sir.
No, first set has 3 members and you get 8. The second 4 members and you get 16.
Yes, sir. So if you have
members, then you get 32. So how would you relate the number of members with the number of subsets? What kind of equation you could come up with?
It's like 2 times something, sir. Because as you realize, it's like you're multiplying the answer you get times 2 again to get the next amount that you would get coming up in the other set.
Okay, all right. You're on to something, Ms. Waysam. Anybody else would have been thinking about the question and probably can come up with some idea? All right. So if there are n members in a set, the number of subsets n is given by the following formula. So if you have n, big N is the number of subsets, and small n is the number of members in the set. So based on what we were looking at, the first set has how many members?
3. 3 was in the first set.
Right. So if small n is the number of members, then for the first set, small n would be equal to 3.
3.
And if you substitute that 3 in this formula where the small n is, you would have the number of elements to be equal to 2 to the third power. And if you do that calculation, that will give you what?
8.
2 times 2 times 2 times 2. And if you multiply that out, you get 8. So it means that the number of subset that you would get would be 8.
Oh.
Is that clear, students? So for the second set, where small n would now be what?
4, sir.
4. Then big N, which is the number of subsets, would be 2 to the
4th power.
4th power. And that would give you 2 times 2. Oops, sorry about that. 2 times 2 times 2 times 2. And you multiply those out, you get 2 2s, 4 2s, 8 2s, 16. So you will get 16 subsets. Is that clear to everybody? How the formula works?
Yes, sir.
Raise your hand, let me see. All right, so what it means then, once you know how many members in the set, you can use this formula to determine how many subsets you're supposed to get, right? So without listing the subsets, this formula can tell you how many subsets you ought to get. All right, guys? So everybody should be good with that. So don't forget the formula though, because sometimes you may be asked questions.
Sir,
Yes, go ahead, miss.
sir, can move back to the slide before this? I'm not finished writing.
All right, so Miss McIntosh,
Yes, sir.
right?
Yes,
All
sir.
right. So the slides are they're on the website. So all that you have written here, you can access it by just clicking on September to December notes, and you look for the topic and you click on that, then you will get the slides that we are going through. All right, so you don't have to really kill yourself to write and keep up with what I'm doing. All right, miss?
Okay, sir.
Right. So when you get the time, you can just go and click on September to December notes. A list of the topics that we would have covered already will come up, as well as there are topics that we have not covered yet. So we are at subset right now. So you would, all that come before subset, those we would have gone through already. And anything that come after the subset will be things that we're going to come in that same order, because all the topics are there in the order in which they will be taught. All right, so that would be for everybody who is wanting to follow up with the notes or wanting to read ahead of the class. You may just look at the notes so you know what topic next, and you read up on that topic before you come to the class. All right, so here we now have this formula, so we know that we can use this to determine the number of subsets that we can derive from a set if we know how many members we have. Now, note briefly, if A is a subset of B, and the intersection of A and B must be A, since all the members of A are common to both A and B. All right. So this is a statement. Now, what this statement is saying that we can relate subset to intersection of set. Now, we have not yet looked at intersection of sets, but what intersection of set means, you have those members that are common to both sets would be in the intersection. Now we will see what all of that look like in terms of diagrams as we move along. But just to illustrate what this is saying, if A is a subset of B, all right, let me see if I can give you a little better diagram than that. All right, so here you have, say, the circle, which is, let's call that circle B. And then now, within the circle B, we are going to draw another circle and say, let's say that that circle is A. So what we know that this would be the set A. And this would be the set B. Now, if A is a subset of B, it means that every element of A is in B, because the entire circle A is in B. So every member that are in A are also in B. So in terms of the intersection of A and B, we will be considering all those members that are both in A and B. Now, since the set A is in B, then whatever member is in A is also in B. So we can say A intersect B, meaning the member that are in A as well as B would be the set A. Is that clear to you guys? Raise your hand if you understand. All right, let me see the hands of those who don't quite understand what I'm saying. Is there anybody who don't understand? All right, Mr. Paisley. Now, so an intersection of sets, generally you look for overlapping sets when we're dealing with intersection. So if you have two sets, say set A and set B, and the two sets are overlapping. Now that region where they overlap is known as the intersection. So this region is the intersection. Now, any member that are in this section would be in part of A and part of B. Are you seeing that, Mr. Paisley?
Yes, sir.
All right. Now, this set A in this one is not really just overlapping, but the entire set A is in B. So if you consider the members that are in A, which are also in B, would be everything in A. You follow what I'm saying?
Yes, sir.
Right, so we can say that in this case, where A is a subset of B, the intersection of A and B is just A, because every member of A would also be a member of B. Is that clear?
Yes, sir.
All right, so that's what this statement is saying, that if A is a subset of B, then the intersection of A and B must be A. since all the members of A are common to both A and B, because intersection means those members that are common to two or more sets. All right, so if you have two sets and they're overlapping in that common area where the two of them overlap, you will find the intersection. But if the overlap means that it is a subset, then that subset would also be the intersection. I hope everybody is fine with that. So with that said, I'm going to be moving on. All right. Now here we have an exercise that we're going to be going through and do together orally. And so this exercise here says that you have to list the subsets whose members are all odd numbers of A. Now, if you notice here, the set A would be this set up here. And from that set, you are to list the odd numbers of A. Then you are to list the even numbers of A. Then you are to list the prime numbers of A. And then all the numbers in A that are divisible by 2. So you are to list them. So for this first part A, what are the members that are odd numbers? Come guys, start and help me to list this. What are the odd numbers in this set?
3, 5.
So we have 3, 5,
11,
9, 11,
and 13.
13, 15. Those are all odd numbers. I hope everybody knows what odd numbers are. Can somebody tell me what odd numbers are?
Numbers that can't be divided by 2 without leaving a remainder, sir.
All right. It's not, all right. So I wouldn't just say numbers that can't be divided by 2 without a remainder. I mean, even though that is true, but in a more appropriate way, we would say numbers which, when divided by 2, leave a remainder 1. All right? So any number that you divide by 2 and you get a remainder of 1, those are odd numbers. All right, guys, everybody clear with that? Raise your hand. All right, so that's it. That's the definition of an odd number. Any number that you divide by 2 and get a remainder 1, it is an odd number. All right, here now it says that you have to list all the even numbers of A. So all the even numbers of A now would be what?
6, 8, and I think it's 12.
So we would have 6, 8, and 12.
Yes, sir.
All right. So we'd have 6, 8, and 12. All right. All the prime numbers of A now.
3, 5, 11, and 13.
3, 5, then we have what? 11
11 and 13.
and 13. All right. So by now, everybody knows what prime numbers are. All right, what about all numbers that are, all numbers in A divisible by 2, meaning that If you divide them by 2, there will be no remainder. What are they?
6, 8, and 12.
6, 8, and 12, sir.
Right, so it means that this now would point to that set, which would be the set of even numbers. So that tells you something about the definition for even numbers. What are even numbers?
Numbers that can be divided
Easily
into
divided
2.
by 2 without leaving a remainder.
So any number that are divided exactly by 2 without a remainder, those are even numbers. All right. So those are definitions that you need to keep in your mind. All right. So moving on.